Hello, in this episode we have my friend and fellow SAP developer advocate Rich Heilman on to take us through the charity component of the developer Keynote repository for SAP TechEd 2020. The charity component is a component written in ABAP running on SAP Business Technology Platform, that's steampunk to you and me, and it essentially is the next link in the chain that we built for the demo. It takes event messages published to the SAP Event Mesh based message bus, processes those messages, stores data, retrieves data from the S/4HANA cloud system via APIs, and then also makes an OData service available for further consumption by a UI component. Let's get started with Rich right now.
So Rich, thanks for joining me. I'm looking forward to this conversation where hopefully you're going to explain to me what the charity component is, what it does, how it works, and so on, right?
Well, I'll certainly do my best.
I'm sure you will. I'm sure you will. So I can see on your screen already that you have the Event Mesh administration panel up. And we did see this in the developer Keynote itself. And this is almost like the entry point of for the charity component. So if we think of the components that come up before this, we've got the brain. And the brain does a number of things. And the final thing it does, as it were, before handing off is throw up into the air an event message to the topic internal charity fund increased, right? Mm-hmm. And so I guess you're showing me this screen because you're going to explain how your charity component on the ABAP stack catches that and then starts to do something with
it. Exactly. So, I mean, the driving force behind the entire application for the developer Keynote is driven off the event mesh, and this is no different. So for the ABAP side, we're basically listening for a particular message, and then we're going to do something with that.
Yeah.
In order to do that, of course, we have to set up a few things. For example, I have an ABAP queue here, which is just it's just the baseline object here. But on top of that, we have the queue subscriptions, where I'm tying the ABAP queue to a specific topic name. And this charity increased topic name is what the
message is published to, right?
Exactly.
In the event mesh, you can publish a message to a queue directly, but you could also publish a message sort of slightly more indirectly to a topic. You don't really care who consumes it,
right?
But because you, the charity component, wants to consume it, you have to create a queue and attach that queue or subscribe that queue to that topic so that any messages to that topic end up in your queue that you can consume.
Exactly. And then on top of that, we have a webhook subscription, which is basically listening on that queue name, which again is listening for that particular topic.
Mm-hmm.
So when our webhook, we can take a look at this.
Right,
When our webhook is configured, that anytime a message comes through, it's going to actually make a call to our HTTP service on the ABAP side. You can see that URL here.
So just to make sure those who are watching, a webhook is basically an HTTP endpoint that you hit with POST, right? And it's a great way of throwing data at a system or kicking a system and saying, here, have this, do something with this.
Yes, absolutely. And just one thing to note here, when I was configuring this, we use some basic authentication to do this.
Mm-hmm.
It's important to note here that for this component, we have to use a productive instance of Steampunk where we're not able to use the trial because of the limitations behind the trial, where we're not allowed to create things like communication scenarios and communication arrangements and communication users that we've used here to be able to call into our ABAP system using basic authentication. We can't do that with a trial.
And I'm guessing that's
for-
because it's a shared system, right? Multiple people are using that system, so we don't want
exactly.
exposure.
I mean,
and stuff, right?
Exactly. Could you imagine if we allowed people to create communication scenarios out there in a shared system, and they actually tied it back to their systems at home?
Hey.
Yeah, we have a legal
Carnage.
problem there. So, so we have a bad problem there. So for this particular for this scenario, we have to use a productive instance so that we can use those things like the communication scenario and communication arrangements. So if we just take a quick peek at that configuration that we've done in the productive instance. Okay, so if we just take a look at the communication scenarios, we have one out there for for our customer donation credit communication scenario for webhook. We have that out here, which we've created. And then we have, of course, all the things that go along with it. We have the communication arrangement, the communication user, which is has a username and password associated with it. But as you can see here, we have these two services, one of which is this HTTP service, this this REST service. This is basically say for this service, the only way that you get access to it is via this username and password that is configured in the communication scenario and arrangement. Later, we'll see the this OData service that the UI will consume, but that also passes through this the same configuration with the username and password.
So just for my benefit and those watching as well, I can't remember whether we had time to show this particular page or in the keynote itself, but this is basically just standard configuration in the Steampunk ABAP system that allows you to expose services for consumption or for production.
Exactly. We didn't have time to cover this in the keynote, but this is the correct way to tie these things together using basic authentication to be able to call into the ABAP system. So we just wanted to show that here. Okay.
Cool.
All right. So let's get rid of that. So at this point, I mentioned that we had the HTTP service. Let's go ahead and look at that. So if we go to the ABAP system, and we'll open up the CDC REST service, which is what
so that's the URL we just
earlier.
saw, right? That's the URL that is the webhook endpoint.
This is the webhook endpoint that we had in that configuration. Yes. And what we have here is the handler class, which is tied to this service. So we can look at that. And this might bring back some memories for you, PJ.
Seriously, line 16 is, that's if I were to get a tattoo, it might be that.
I thought you'd like that. But yeah, this is a basic HTTP service extension. We implement that interface, and then we get access to the handle request method, and it's basically whatever we want to do here, right? You'll see the first section here. I usually, when I'm working with request and response, I usually, and maybe some complex payloads, I usually put an example of what the payload looks like in my source code so that I can reference it.
Yeah, and that's looks familiar as well, right? Because that's what the cat brain is emitting.
Exactly, and I just wanted to have that here so that I could see what I was doing with the deserialization and whatnot. But you'll see here the main area that I'm interested in, of course, is this sales order, customer ID, this creation date, credits, and sales order. So I'm going to pull that out of the message. So if I come down here, the first thing that I'm doing within this method is basically getting the request method and then doing a case on that. Let's not pay attention to the get or the options, but what's more interesting is this post here.
Yeah, because every webhook is normally a post, right?
Exactly. So basically what we're doing here is just calling the get text method of our request object, just bringing me that payload, that JSON payload, and I'm deserializing that using the standard class to do that. And it's putting that data into this LS payload. And if we go look at LS payload, let's see what that looks like. Well, basically the way I have it is it says of type TS payload, and TS payload is basically this whole thing.
So you've basically described what you've got in the comments there, the event message structure. You've described that in types.
Yep. So that if I declare everything, as the same as the JSON that I'm expecting, all I really have to do in the post method here is call this, and all of a sudden I have a structure with embedded tables in it that contain the data that I want. For example, ls payload dash data dash data dash data. This last data is actually the data that I want. This, if we go back and look, right, data.
Yeah, the great grandchild, basically.
Yes, exactly. And basically this is exactly what I want, and I have it in that structure.
In a way, I mean, it's just
data.
made me think that this is ABAP's way of doing destructuring.
Yep. And what's cool here is because I have access directly to that data, I'm just doing a modify against the underlying table. So modify the database table from that structure, boom, I have it inserted into the table.
So this table is what exactly?
This table is where we're storing all of our data that's coming in from the messaging.
Right, yes, because the charity component is the only component in this whole ensemble that stores anything, that persists anything. The brain doesn't, the converter doesn't, the proxy certainly doesn't. But this is the central hub of what we're trying to collect here from a charity perspective.
Right, and we can go ahead and take a look at this table. We can do a right click and say open with data preview, and we can see all of our data here. Okay?
Right, that's starting to make sense now. Yeah,
and you can see that we have a additional record down here, and this comes from my simulator, which if we wanted to, we're not going to do it in this session, but we're not set up to actually emit a new message from the event mesh. So we'll simulate the triggering of our webhook, and the way we can do that is if we go to our class here, this trigger webhook sim. Let's take a look at that.
So when we were building the developer keynote content, this is how you did it. We all worked independently and then came together, and you use a simulator to simulate the stuff that the brain would eventually be sending, right?
Right, exactly. Because I mean, I have to. If we're working independently, I can't wait for other things to happen before I can work.
This is real life.
Yeah. So this class, for lack of a better word, I'm hijacking an HTTP
in the nicest possible way.
In the nicest possible way, I'm hijacking the HTTP client framework here in Steampunk to basically call my handle request method directly. So if we look here, I'm getting an HTTP client object, and then I'm basically getting a dummy request and dummy response object just right out of the gate. And then I'm actually taking the data, the payload, right, and putting data into the payload. And since we already have a record out there for this date, let's do another date here.
Yeah.
Let's do the 16th here. Let's change this to 30 or something like that. How's that sound?
Sounds good.
Okay. So let's go ahead and activate that a while so we don't forget.
Actually, while we're activating, line 19 really catches my eye because isn't that class the name of the handler class that we started looking at, right?
Yes. So if we go back here, this is the HTTP handler class. And like I said, I'm kind of hijacking a couple things here, one of which is our HTTP handler class. So I'm getting an instance of that, all right? And down below here, after I set the payload into the request object, you'll see that I'm calling our handle request with the request and the response objects that I've mocked up here. So
that's really cool because it shows that with the whole ICF sort of class and interface layer, you can really easily simulate for yourself request objects, response objects, call handlers, look at the responses, and do it all sort of, super localhost.
Absolutely. I wouldn't suggest to do this all the time, but
Not for
it
production.
works. It works for our scenario here, where
Yeah.
I wanted to basically reuse what I had in the handle request
Yeah,
without
makes sense.
compromising at all. So this is the best thing I could come up with. So if we go ahead and actually run this simulator, say run as console database updated successfully for customer 10. So if we go back and look at the table, hopefully we have another row here. Actually, it overwrote the original row.
Oh yeah, the other. Oh, is that because of the key fields are just sales order and customer ID?
It's because of the because we're basing it on it's an update, right? So we're always
it's not going to be the same
based
sales
on,
order, is it? Yeah.
right. It's always going to be, if I wanted to be this to be unique, I should have changed the sales order number, but we're actually updating in this.
In a way,
case.
if we had got a second record, that would be a bigger issue, right?
Right. I mean, it would just do aggregation in our next step,
yeah.
which we can do that. I mean, let's go back and do that. So if we wanted another record here, let's call it.
You were going to add one to that, then thinking, oh, hold on, the number's going to get too big.
let's change this to.
Oh, put it 4711, 47.11.
Where at?
47.
47.11.
That's a very special number.
Okay.
Let's see if anybody who watches this figures out what I'm talking about.
All right, run. Okay, let's go back to our table, and we should have another row here. Yep, there we go. So we have another row here. And during our next step, we'll actually aggregate these together, and we'll see that in our CDS view, which is our next step.
So far, what's happened is that a message has been captured on the queue from the topic. The event mesh has used the webhook to throw that message to you. It's been handled by this handler class. We can see through the simulator that the handler class has now stored that data in that actual table, right? So that's where we are.
That's where we are. Now that we have the data in our table, we want to expose that data using the ABAP RESTful application programming model. We want to expose that as an OData service to our user interface. And we have several layers that we have to do here using the wrap. The first layer is what we refer to as our business object layer, our lowest layer, our interface view layer. Okay?
Like the closest to the persistence layer, right?
Exactly. This is the closest to the persistence layer. This is where we want to basically have all scenarios covered, so that our consumption, our projection views can feed from that.
Yeah,
right?
they can pick and choose from that as they need
right.
to.
So we have root view, the name of our view, and then of course we're selecting on the database table itself. Okay, sales order, customer ID, creation date. And what I have here is a calculated column because I don't want to have to store redundant data, which if I stored month and year, it kind of would be redundant, right? But I'm calculating it on the fly using this code here.
Beautiful.
So concatenate, substring, create date. So I'm taking the year and the month and creating that as a column called creation date, month and year.
So the first substring is basically grabbing the year, the 4-digit year, and the second substring is grabbing the 2-digit month, right?
Exactly. Yep. And that's what we would see in this column. And we'll use that later to do aggregation against, right?
So while we're here, there's, I think I said at the time I was sort of, waxing lyrically about the relationships between, I did it again, relationship between CAP and RAP. But here I'm already feeling that this is a bit like the CDS that you write in CAP at the schema level. So
similar.
Yeah, all scenarios are covered. You've got all the entities. There's only one here anyway, so that's fine. But basically, it's not consumer dependent at this level, right?
Right. Yep. So then we have credits and sales org as well that we're going to expose in this interface view. Okay. So that's our lowest level business object. Now, in this case, we want to do some aggregation, okay? Because we want to report on, the total credits for the customer per month. Okay. So what I've done here is I've created another interface view on top of the business object view with the same name with underscore R at the end of it. I'm calling this our reporting interface view. And you'll see that we're just doing a select against that earlier view, pulling out customer ID and the year and month. And you'll see here that I'm doing a sum on the credits. So doing that aggregation at this level.
So this is still, I'm noting that the actual name is still Z_I. So we're still sort of in the interface view sort of, foundation area.
Yes,
You just
yes.
added another little thin layer on top just to do some aggregation.
Right. This is kind of like our intermediate, I call it the aggregation level, because it's not quite a projection at this point.
Yeah.
We're still at the lower level. We're just the aggregate over top of the lowest level.
And we're putting it here because we're expecting that we may have multiple consumers wanting this aggregation of the credits, right? So let's put it here rather than in individual consumer views.
Exactly. Yep. So then once we have this aggregation level, we create our consumption or our projection views. Those names are kind of used interchangeably. They started out by being called consumption views, and then we've changed it to use the term projection. But basically, it refers to the same thing. So when I say consumption, I mean projection, and when I say projection, I mean consumption. So we have this, right? But you see a lot of artifacts out there, especially in my work and some of the examples. You'll see this C here as and that actually stands for consumption. So you'll see some of those relics coming through. But you'll see here, define root view, the name of our view as projection on our reporting interface view. Okay.
So again, this is yet another exact parallel in this case with CAPS, CDS in CAP, and where you're defining at the service layer, you're defining something that is a projection on something that's lower down.
Absolutely. Yep. So here we have the customer ID again, and the month and year, and taking it, and we have total credits here, but we're also taking this one step further, because the user interface is going to want to have a little bit more information than just customer ID. I mean, customer ID sometimes is kind of meaningless. We want the customer name, but you'll know that customer name wasn't passed to me via the payload in the message. I'm not storing it locally in our database anywhere. Where am I going to get that? Well, we're going to use a virtual element here, and we're going to use a class in this particular case, CDC customer master. We're going to go out and get the customer name from the source, from the S4HANA box system.
So let me get this straight. So you're defining here a property called customer name. The property doesn't even exist. But not only that, you're pointing to an ABAP class that is going to resolve the value for that property. And that ABAP class itself is going to resolve it by making a call to a backend S4HANA cloud system.
Yep. And we're going to show that right now. So if we go to that class, we implement an interface, right? Calc element read. And in this method calculate, this is where we would put the code to do that. Now, I could just, and I have code out here where I've done that. I could just use the HTTP client to make the call, right?
Like
I have the URL from
bam, do it
directly. I'll go out with brute force and just boom, give it to me, and come back, and I'll take the JSON and do what I will with it.
Yeah.
But I wanted to do something else and make it a little bit easier on myself. So I went and I explored the service consumption model way of doing things.
Okay.
So we have this object here, the service consumption model. And basically, this is kind of like a wizard that you can go out and get the EDMX file from the service, from the Business Hub. You can give this wizard the EDMX file, and it generates all this good stuff for me. For example, this view here, it generated for me. I didn't have to code all of this, but this is basically all of the data that is being served up by the service that I want to consume. So customer
So
billing
this
is
view
bought for customers.
reflects the EDMX that you
Yes.
grabbed for the remote service. This remote service is the some customer
Yep.
information OData service, right?
Yep. You can see here the entity that I'm pulling is a customer,
yeah.
right? So, so basically, this creates an interface to that service. And then the neat thing about this is it actually writes my code for me. So if I drop this down and say read list, it's now giving me some code that I can copy and paste into my class, which I've done here, right?
So that explains that data definition that referred to something that looked as though it was a generated name just above there. Yeah, okay.
Yes, that was generated. Yep. During the wizard of the service consumption model wizard. So I've taken their code that it's generated for me. I've added in a couple of things, like for this, for example, we have to point to our service URL
proxy
here.
Yeah, there's the proxy that we have, the proxy component, sandbox component.
Right, and we use the code that it supplied to us, right? And we make the call with this execute here, and we get the response, right? And we say get the business data, and bring it back in the LT business data internal table. Now this contains our customer names. Well, that's fine. Now we have to take this data and merge it with the original data, and we have access to the original data as well because it comes in through our method. IT original data is the original data that's coming in from our view. So we loop through our original data, right? And then we read against the business data that we just pulled in from the service, where the customer is equal to our customer ID,
and then you update
and we're updating the customer name on the fly.
Because you're doing it with the reference as well. That's it. That's all you need to do. And also, this is another parallel between RAP and CAP because I think actually in the Keynote, as we developed a Keynote, we imported the sales order API EDMX right into CAP, and that did a very similar thing. It generated season in that case, and it gave us the ability to consume that service, and this is the service consumption equivalent in RAP, right?
Yep, exactly. So that's how we're bringing in the customer name. Okay, so if we close all of this down here,
well, yeah, this is where we started out, right? This is at the consumption, the projection view with this virtual customer name. That's where where the data comes from.
Exactly. So now we're at the point that we want to expose this view, because this is the data, customer ID, month and day. I'm sorry, year and month, customer name, and total credits. This is the data that we want to expose as a service for the UI. So now we have to take this view and expose it. And we do that with a service definition. So if we go up here and we look at this service definition, this is all that it takes to actually create the service definition. We give it a name, and we say expose this view and give it an alias, credits by month.
Again, yet another parallel. I mean, I'm thinking here at the service definition level, at the serve level in CAP, we're defining a service name. We're defining then within that service entity sets. Effectively, what will effectively be if we expose this as OData, entity sets, right? Credits by month.
Yep. So at this point, we're still protocol agnostic. So we need one more object on top of our service definition, which is called a service binding. So we go ahead and open this up. You can see that it's using the service definition that we just talked about. And the service binding is OData v2 UI. There are other binding types.
Yeah, I've always wondered about this. Yeah, exactly.
We support the ENA binding type, and we have OData v2 UI and OData v2 web.
Right, yeah.
And as well as both of those versions for v4. So the UI, this gives us a nice Fiori preview, which we'll see in a second, and the web binding configuration
That's more like a
sets
Swagger
us up.
style thing, isn't it?
Yeah, something for that. But we have, again, this gives us this nice UI, which we can preview. So if I'll highlight the entity set credits by month here and click preview, and this will bring up our preview.
Mm-hmm.
And if I click go, I get the data that's in our table. You notice customer name is coming in here.
Beautiful.
That's coming in on the fly, right? Via our service consumption model, right? And you can see down here that our records for customer 10 that we put in there for
That was
megabytes.
that 9999, right? Yeah.
Yeah, that was that customer. Those sales order. It's being aggregated up to the values that we had in there.
And this is only part. This preview is basically powered by Fiori elements, and the annotations that you also showed. We didn't talk about them, but the annotations that we saw in those interface and projection views, right?
If you look here at the metadata extensions, which we didn't cover, but we can look at them now. Basically, the metadata extensions here that I have defined is where that UI is being generated from. Yep, that's where that comes from.
The power of declarative coding, right?
Exactly. So then the final piece here, of course, is the service URL itself. So if we just click this service URL, this is the service that we're handing off to the UI. So I could say credits by month. Here, this is the service that the UI is going to consume. You can see here we have all the data that we require. We have the customer ID, creation date, month, year, customer name, total credits.
So this is basically this one entity set. In fact, yeah. Can we go back to the previous one, the service definition? Go back in the browser, just with the back arrow. No, on the that one there.
Do that.
So we've got the right in the middle there. It says credits by month, and that is a reference to the entity set that this service has, and it's that single entity set that then the UI component, which on this series of hands-on SAP we haven't covered yet. But that's the thing that the UI component is consuming in order to generate those beautiful graphic cards.
Yep, absolutely.
So can we have one more look at the entities again with the values, the credit amounts, and everything? Go forward again. Yeah.
Oh.
Figures. You can see that the authorization level is doing its job.
There we go.
Right, exactly. Yeah. So we've got the customer. So just in summary, we've got the customer ID, and that really is the essential piece of the essential property that isn't actually special. You get that in the message that comes through the event mesh, but every other property, all those other three properties, they're all basically generated, right? You've got the creation date, the year and month, basically, which you are joining together. You've got the customer name that's coming through super dynamically with the ABAP class that you defined to go and get that data. But also, even the total credits, that's not an aggregation. Exactly, that's not a value that you're storing directly in the persistence layer. That's being aggregated, if I remember rightly, by the interface report view, right? The
exactly.
Z underscore I, Z underscore something underscore R.
Yep, exactly.
That's amazing.
It's this view here. Yeah, this one. Yep.
Awesome. And I think with that, that's more. We've covered end to end now, have we? Yeah, I think we have. We've covered end to end the charity component from the messages that come in to everything that it does to what it produces.
Yep. That's basically it.
Awesome. Rich, thank you so much for your time.
And
folks watching, I hope you've got some good stuff from this. Let us know what you think. Thanks very much, Rich.
Yep. Thanks, DJ.
Cheers.
Cheers.